Technology we use in astrophotography has evolved, and I dare say it has changed so much that given time, it may well contribute to our understanding of cosmology, because our ability to capture and portray the cosmos has advanced so much that even small amateur telescopes can now produce images on par with the great telescopes of only a generation ago. Just as importantly, astrophotography has the potential to become a ship of the imagination. Using it, combined with a little clever CGI, can transport us across the cosmos and reveal the universe in a way that, not long ago, was confined to imagination alone. In fact, only a moment ago, our ship of the imagination departed low Earth orbit to set out upon a voyage that will take us across the galaxy, through 45 million light-years of the Gulf of intergalactic space, to a false cluster of galaxies in the vicinity of NGC 7331, also known as the Derlick galaxy group. It's still a ways away yet, and just now, we're just coming above the galactic plane of the Milky Way, where thickets of dark dusty clouds are silhouetted by a glowing haze of stars. As we move beyond the plane of the Milky Way galaxy, the stars up here become thinner and thinner, though as you can see, stars extend out well beyond the Milky Way. As we transition into the depths of intergalactic space, we experience the reality of the darkness of that space. The vast majority of objects beyond our galaxy are too dim for the human eye to see. So, once beyond the scattered stars in the outer halo of our own galaxy, we must amplify the light. Fortunately, our ship of the imagination carries the optical equipment to do that. There, now let us continue to our destination. While in our galaxy, we were traveling at a fantastic 100 light-years per second. To get to the Derlick group in a reasonable amount of time, we'll need to go much faster than that. In fact, we're going to accelerate to 250,000 light-years per second, a speed unfathomable to anything but the ship of the imagination. There's the Derlick group, directly ahead. I referred to the Derlick group as a false galactic cluster. That's because the closest galaxy, NGC 7331, is some 300 million light-years from the smaller galaxies known as the fleas in the distance. NGC 7331, now coming into view in front of us, is 45 million light-years away. I spent several nights photographing this cluster just last month and was lucky enough to capture a rare and titanic event, the eruption of a supernova. It is there within the red circle near the core. The death of a star is the birth of a supernova. Perhaps, just perhaps, we might get lucky and catch this supernova right at the very moment of its birth. There it is, the star just now exploding. Only stars with at least 8 times the mass of our Sun can become supernovae, and when they blow, they destroy the star systems and potentially everything around. But they also create the heavy elements from which rocky worlds like our own Earth are made. Indeed, without them, neither Earth-like planets nor life as we know it could exist. Among the hundreds of billions of stars that comprise a galaxy, no one star is noticeable from a distance. As you can see, even this close, most of them only appear as a haze. But in the last moments of life of some stars, when they erupt as supernovae, in those brief few weeks, they can outshine the entire galaxy where they were born. But we can use modern telescopes to look far beyond even a distant galaxy. Let us consider for a moment the galaxy Messier 82, also known as the Cigar Galaxy. At 12 million light-years from Earth, it is much, much closer than any of the galaxies of the Derlick group, and we are traveling there now. The Cigar Galaxy is being thrown into chaos by the gravitational pull of its neighbors, especially the galaxy known as Messier 81. This chaos leads to the collapse of the dust within the galaxy, resulting in a tremendous rate of star formation, estimated at some 10 times the rate of star formation in our own Milky Way galaxy. All this activity is also resulting in the eruption of its gases in the form of violent jets to the galactic north and south of Messier 82. Though as fascinating as this all is, if we look just above and to the right of the galactic plane, into the far distance from 3 to 4 billion light-years, we discover the true potential and depth of modern astrophotography. For out here, in the deepest black of truly cosmic distance, we find a false cluster in the form of a trio. The galaxy LEDA 2732338 which is 2.867 billion light-years away, and the galaxy SDSS J095335.94 plus 694746.8, which is 3.7 billion light-years away. And, amazingly, somewhere at a middle distance between the two, there is a quasar, DWH M82-4, at 2.952 billion light-years away. And though it might sound astounding to be able to image objects like these with a simple, amateur, but modern astrophotography rig, this does not even begin to touch the range of possibilities. This is a group of galaxies in a region about the size of the full moon in the vicinity of NGC 4784. And in this image, some 2,700 galaxies ranging from distances of hundreds of millions of light years to tens of billions of light years have been revealed. NGC 4784 itself is estimated to be about 176 million light years from Earth. But there are some pretty incredible things also revealed within this image, including multiple events of gravitational lensing like down here, and also 31 quasars scattered throughout the image. And of particular interest to us is object SDSS J125842.87 plus 281314.8. It is a quasar located right up here, and it is at the unfathomable distance of over 21 billion light years away, almost halfway across the radius of the observable universe. All this shot with an 8-inch or mere 203mm Schmidt-Cassegrain telescope, using a decent but ordinary astrophotography camera and filters. Let us return to our home galaxy, the Milky Way, and explore some of the wonders that are not close, but nearby in terms of stellar or cosmic distance. Beyond Earth, there in the distance, is the constellation of Orion. I'll circle it. The Orion constellation is a particularly fascinating region within our galaxy, because it contains, among other things, one of the largest stars known, and soon to go supernova, up here on the top left. It's called Betelgeuse, though it's pronounced in a variety of ways, and probably none of them are correct. At least, not according to the original language. And right down here is the belt of Orion. Below the belt is the famous Great Orion Nebula, a nebulous region of star formation so active and bright that it is visible from Earth. However, it is not the center of our interests, at least not for this voyage of the Ship of the Imagination. Our focus is rather Barnard 33, the very famous Horsehead Nebula. It is much dimmer, and to be seen must be observed through a telescope, or we will have to get much closer in our Ship of the Imagination. The Horsehead Nebula is a small dark nebula that is a part of the much larger Orion Molecular Cloud Complex. And unlike the distant galaxies millions to billions of light years away that we were just observing, it is a mere 1,375 light years away. Now, that distance is not to be undervalued. To date, the furthest mankind has ever gotten from Earth is a mere hair's breadth beyond the solar system by way of the Voyager probe. And should we decide to invest ourselves in the technology, a ship using our best modern rocketry science would require 100 years to get to the closest star, Alpha Centauri, a mere 4 light years away. But still, Barnard 33 is close enough to observe in great detail using modern telescopes and astrophotography equipment. And we are just now making our final approach. This is a dark nebula, and much of the detail within Barnard 33 is hidden in shadow. But in 2013, NASA used the orbiting Hubble telescope to take an image of Barnard 33 in infrared, revealing a degree of both beauty and detail and scientific information heretofore unimagined. This is that famous image. But the capabilities of modern astrophotography have come a long way, and while I do not have an infrared-capable camera, a modern camera operating in the range of the visible spectrum is capable of capturing so much light that much of that hidden detail can be revealed regardless. And you are seeing that here, where I'm using my SCT telescope and my cooled monochrome camera combined with LRGB filters to reveal much of the dark structure of this nebula. Shooting in LRGB reveals the visible light spectrum, also portraying the colors much closer to real than the NASA image. Cloud structures rolling off the dark nebula are easily discerned, as well as areas where nascent stars are first coming into being. The cosmos is vast, and we could spend countless lifetimes going from one site to another, seeing all the things modern astrophotography cameras and telescopes are capable of revealing. But for today, let us take one last journey. Let us voyage across the plane of our own Milky Way galaxy, traveling through the dense haze of stars and dust in one of the arms, and take a close look at what to me strikes me as one of the quirkiest and most unusual objects in the universe: globular star clusters. Now, globular clusters aren't uncommon. In fact, around the Milky Way alone, they're estimated to be at least 150, and plenty are to be found around other galaxies. But what is unusual about them is they are like a tightly knotted tangle of stars. Many galaxies, which can consist of anywhere from thousands to millions of stars. No one is quite sure how they formed, but they tend to have some characteristics in common. They are virtually free of dust and gas, and their stars tend to be old, having formed near the very beginning of the observable cosmos. And yet, the story of star formation within globular clusters is complicated. It was not long ago thought that most of their stars formed at nearly the same time from the same molecular clouds. But it has been found that many star clusters show evidence of more than one generation of star formation, demonstrating that stars formed, died, and new ones were formed within star clusters. The question is how? As a rule, they lack dust, and they also have low amounts of heavier elements. What happened to the materials that formed them? And since star formation occurred in them over time, why do they not contain more complex heavy materials? There are many possible answers, such as perhaps star clusters orbited through molecular clouds, inciting new periods of star formation. Though it is also entirely possible that our current theories about the formation of the universe are far from correct, and there is a great deal more science to flesh out. A fact findings from the JWST telescope are revealing all the time. The universe is a far stranger, more wonderful and complex thing than any of us ever imagined. And this can be revealed not just by orbiting telescopes and the great earthbound telescopes of modern professional astronomy, but as the technology behind modern amateur astrophotography progresses, it too is opening our eyes to the wonders and complexities of the cosmos.